Well, in the previous video, we have discussed about consequences of applying various access specifiers and modifiers on class. Current topic is applying access specifiers and modifiers on variables, constructors, and methods. We'll initially start with um, consequences of applying access specifiers and modifiers on variables first. Coming to the variable declaration syntax. As we already discussed, about the syntax of declaring class, variable, constructor, and method. Every class construct, every participant in class begins with, not must, I don't say begin with, must begin with. If possible, they begin with access specifier first, then followed by access modifier. Even coming to the variable also starts with access specifier first, access modifier next. If it is class starts with class declaration. Variable starts with the data type, followed by variable name, or we call it as identifier or property, or variable name, property, identifier, field. People call it with different names. Is equal to initial value or initializer, or literal we'll call it as initial value or literal or initializer. And access specifier, access modifier, data type, variable name is equal to value. This is the declaration syntax of variable in Java. In almost all the object-oriented programming languages, we follow the same pattern. Access specifier first, access modifier next. Data type, because of it is variable name, variable must belong to any one of the primitive or secondary data type. Primitive data type means what primitive data types you can apply: byte, short, int, long, float, double. These are primitive data types. Secondary data types, array type or any class type. These are secondary types, including string also. And the data type to the variable can be belong to any primitive data type or secondary data type, class or array reference. So then followed by variable name is equal to its initial value. So which part of variable declaration is the most common one and mandatory thing is only data type and variable declaration are compulsory. Access specifier is optional, access modifier is optional, and assigning initial value is also optional. In the previous slide, if you look at, these are some of the, actually I kept heading as variable declaration syntax. This was the actual part. But before and in middle of preparing this slide, to the example reference sake, I've mentioned all the list of possible uses of variable declaration here. So here I declared int I variable. So what all involved here is only its data type and variable name. No access specifier is prefixed, no access modifier is prefixed, and no initial value is assigned here. Then followed by this one, access specifier, data type, variable name. This one, variable name, data type, variable name is equal to its value. The next coming to this, access modifier, final, data type, variable name is equal to value. This is access specifier, modifier, data type, variable name, data type, variable name is equal to value. And here access modifier, data type, variable name is equal to value. Access modifier, data type, variable name is equal to value. And you see, there is a possibility of writing access specifiers and modifiers in prefix to the data type and variable, but these two are compulsory, mandatory. Rest all are optional, and I can say they are optional. Property, even including initializing value is also optional. So this is the example of variable declaration here. So while declaring variables, always keep in mind you prefix access specifier first, the next access modifier, then followed by data type, variable name, data type, variable name is equal to value. This is the standard syntax you must follow while declaring variable. That too, remember this type of syntax must be followed only if you declare variables in a class level. This type of syntax, access specifier, modifier, data type, variable name is equal to value. This entire syntax must only be followed when you're declaring variable at class level. If you declare variables inside a method, if you declare a variable, access specifier is not required. Anyway, if fractation comes, we'll discuss. Now, coming to the access modifier also, to the variables declared inside a method. Variables declared inside a method is called as local variables. Those variables can only be declared as final, but we cannot declare static also. Only final, and then to the local variables, to the variables declared inside the method, only final modifier is allowed, no access specifier is allowed, and remaining access modifiers are also not allowed. Only final is allowed. Data type, variable name, and initial value, they are common. And we will discuss about them. Coming to the access specifiers. Which access specifiers we can apply on a class variable? See, as we already know, there are 4 types of access specifiers exist in Java: private, default, protected, and public. Private, default, protected, public. Coming to the private, we already discussed this topic in the very beginning of Java programming structure. There we discussed, if any variable is declared as a private, the variable can be accessible only within the class. For example, if you take class A, in the class A, if you declare a variable name called int x is equal to, and if you declare it as a private, what is the scope of this x variable? What is the scope of x variable? See, remember, if a class is given, a class can be used in how many ways? Yes, a class can be used in 2 ways, in 4 places. One is within the directory. A class can be subclass. Class B extends A. Is private variable can be accessible here? No. Private variable cannot be. Private variable can be accessible only within the class. Private variable cannot be even derived into subclass. Cannot be accessed into subclass. And there is one more way of using a class C. If you create object of A is equal to new AF. Then I'm not saying you write directly here, somewhere in the method. If you're trying to access A dot X, here also you cannot access. If you're trying to access X, here also you can't access X. Here you can't access X, here also you can't access X. Why? Because private member belongs only to the class. It cannot be accessed in the subclass within the directory, or it cannot be accessed in the instantiate class within the directory. Similarly, if you go to outside the directory, here also class D extends A, and there is one class E. Here also, if you are trying to access X, here also if you create object of A and trying to access A.X, you cannot do. These 2 classes are classes outside the package. These 2 classes are within the package. B is a subclass of class A within the package. C is an instantiate class of A within the package. D is a subclass of class A outside the package. E is the instantiate class of class A outside the package. Private member is restricted only to the class. Suppose if you declare this variable as default. Default means don't write anything. Don't write private or protected or public or anything. Don't write anything. Then the variable can be accessible anywhere within the package. Anywhere within the package means into both subclass and instantiate class within the package, but not outside the package. అంటే default members cannot be accessible outside the package. That one is very clear. Third, if you declare variable as protected, protected member is having access scope of up to 4 within the class A, subclass within the package, instance class within the package, up to subclass outside the package, and its scope is 4 within the class, subclass within the package, instance class within the package, subclass outside the package. It cannot be accessed in outside the package where we instantiate class A. There we cannot access X. This is about protected. Coming to the public, if a variable is declared as public, then it can be accessible anywhere. Anywhere in sense, anywhere within and outside the package. Within the package, class A, within the class B, subclass within the package, class C, instantiate class within the package, class D, subclass outside the package, class E, instantiate class outside the package. The variable which is declared as public is having access scope throughout the system, within and outside the package. Protected anywhere within the package and up to subclass outside the package. Default within the package. Private within the class. This is about access specifiers and their consequences on variables. Okay. Now let us go to the access modifiers. Let's discuss access modifiers. Coming to access modifiers, how many access modifiers we are having? We are having abstract, final, static, transient, volatile, native, synchronized. Altogether how many? 1, 2, 3, 4, 5, 6, 7. 4 specifiers, 7 modifiers. 4 specifiers, 7 modifiers. 4 specifiers are private, default, product, public. Modifiers: abstract, final, static, transient, volatile, native, synchronized. Out of these 7 modifiers, which modifiers we can apply on variable? On class we can apply only abstract and final. Coming to the variable, we'll try abstract. Can apply or not, we'll see. The next we'll apply final. We'll see the consequence. We'll apply static. We'll see the consequence. Transient and volatile are applicable only on variables, but not on class or method. Transient volatile can be applied only on variables. Native synchronized belong only to method, so that you can remove from the list. Transient volatile, final, static. Only final, static, transient, volatile we can apply on variables. Only these 4, but not this, but not these 2. Abstract can be applied only on class and methods. Native and synchronized can be applied only on methods. Transient and volatile can be applied only on variables. Only on variables. Only on methods. Class and method. So now the race is only between final, static, transient, volatile. That's all. Only 4 modifiers. Here the point is, why can't we apply abstract on variable? See, abstract is applicable only on class and method because abstract means unimplemented. It can be applied only on class and method but not on variable because only class and method are having body, are having logic. Only class and method are having body, implementation, the logic, but not the variable. Variables are not having body, variables are not having implementation. So variables are having initial value. Later on you can reinitialize the value for any number of times. So for the variable there is no meaning saying no, that there is no body or implementation to the variable. So we cannot apply abstract to variable. Unimplemented class exists, unimplemented method exists, but there is no meaning in declaring, there is no Meaning to say that variable is unimplemented. Variable is uninitialized, you can say, but not unimplemented. So abstract cannot be applied on variable. And one more point is variables are just only initialized. We should not declare variable as abstract. That what is clear. Coming to the final. Which type of variables are declared as final? Variable whose value want to be constant forever are declared as final variables. If you ask me to give examples on final, I can give you plenty of examples. I can at least make around 15 to 20 constant variables available in Java API. I can say. One is in the math class, if you go, the pi is one constant variable. Pi is a constant variable. So in math class, pi is one rememberable variable. And next, coming to every wrapper class, right from byte to short, int to long, float to double, except in char and boolean. 6 wrapper classes: byte, short, int, long, float, double. In all the 6 wrapper classes, 2 constant variables are given: min value, max value. And the data type minimum value is assigned to one variable, and maximum value is assigned to one variable. Like the 2 variables given in each wrapper class, right from byte to short, long to int to float to double. Min underscore value and max underscore value. So their ranges are the minimum value and maximum value. Those ranges are assigned out there. You can go and check them. You can print them. And the next wrapper class are completed. That math class is completed. One more example is if you go to user interface programming, as I told you in the morning. In the user interface programming, if you take a component, like say for example label or text field or button or text box or checkbox or ready button, any component if you take it, you can assign each component, and you can not assign, you can hook. Yeah, you can assign, not you can assign, you can position. You can hook or you can position each component in a grid, any one of the 4 sides, 4 corners, and one at center. North, east, south, west, northeast, southeast, northwest, southwest, southwest, northwest, and one at center. 4 sides, 4 corners, one at center. You can place each component in a grid of the user interface anywhere occurs in these 9 positions. 4 sides, 4 corners, one at center. They're all given as a constant variables in some class called swing constant something exists. There that constant variables are there. And similarly in the core Java, there's one class called thread. In thread class, 3 constant variables are given: min underscore priority, max underscore priority, norm underscore priority. The values of min underscore priority is 1, max underscore priority is 10, norm underscore priority is 5. And whenever you write a thread, you create a thread object. To the thread object, you can assign a priority. The priority you can assign using any one of these 3 variables: min underscore priority, norm underscore priority, and max underscore priority. You can go and check in the thread class. On the top itself, you will find those constant variables. So, like that, if I name, there are so many number of constant variables found in each and every package across in so many number of classes. So, final variables are plenty. In our applications also, min underscore is, max underscore is, minimum transaction amount to, maximum transaction amount to, minimum credit limit to, maximum credit limit to. These are all constant variables. Minimum is to take a job, minimum is for swimming, minimum is for karate, like that. Minimum is to join in the school, to join child in the school, like that. You can find plenty of final variables across in Java API and as well as in our programming also. But final variables are variables whose values wants to be constant. Then whose values want to be initialized only once. We want to assign value only once, and that value assigned to the variable do not want to be changed in future. Same variable value want to be utilized for many times. Such variables are declared as final variables. So final variables whose values want to be constant forever are declared as final. Final variable, and one more very important point is final variables must be initialized at the time of declaration. They can't be reinitialized. Reinitializing means reassigning the value. That you cannot do. Here, I am declaring one example, final variable example. To declare a final variable, this is my final variable. Min is for vote. And the minimum is for voting. Minimum age for the voting is 18 years. Min age for vote is 18 years. And how it is declared? It is declared as public final int. And public access specifier, final access modifier, int data type, min underscore age for min underscore age underscore for vote, and minimum age for vote. That is variable name. That is 18. Here, one more very important convention while declaring a final variable is, usually in Java, we'll declare variables and methods with a camel case convention. For example, if I want to write my name is, for example, I should write the starting word of the variable or method in small letters. My name. Next, every word starting letter we will write in cap letters. My name is, again I is cap letter. This is how starting letter, starting word, starting letter, small letter. Thereafter, every letter starting letter, every word starting letter is a cap letter. That's how my name is written. Similarly, to vote, my is for vote, min is for vote, min is for vote. You need to declare like that, variable like this. So min is small letter, A is for a vote, A, F, V are cap letters. So this is called as, camel case convention. Camel case convention. Camel case convention. This type of convention must be followed both for variable declarations and as well as for methods, but not of the constant variables. I don't say constant variables must be written like this, but in order to recognize, see, for example, if you see any variable in a class, you must immediately recognize whether the variable is a constant variable or not. Not only Java, in HTML, in CSS, in JavaScript, right from C, C++, VC++ you go, C# you go, Python you go, PHP you go, Java you come. You go to any programming language, any even markup language like XML and HTML. Even you go to databases also, the exceptions, predefined error codes, everywhere final variables are written in cap letters. Is cursor open? Cursor closed? Some constant variables are there in even PLSQL also. So almost not almost in every programming language, constant variables are declared in capital only for two reasons: one for readable convenience, and second one for convention sake. So if you want to declare the min is for vote, so you write min underscore age underscore for underscore vote, all letters in cap letters so that we can easily read. Readability increases. And second point is conventional wise, convention wise, whenever a variable is found declared in cap letter, it can be immediately recognized as a constant variable. That is how we declare the variable. And coming to, I'll discuss about static later on, transversal later on. Here I'm showing one example on how many ways we can initialize a constant variable. If you declare constant variable, the constant variable is declared as public data access specifier modifier data type variable name is equal to value. But when the final variables must be initialized, is the point. The point here I mentioned was final variables must be initialized at the time of declaration. They cannot be reinitialized. But see, this example. Here I declared one variable, and here I took one class only just for variable declaration, for nothing else. Here one way, first way is access modifier final int min underscore is equal to 18. Access modifier to data type variable name is equal to value. Final int min underscore is 18. So is it correct? Yes, it is 100% correct. Final variables must be initialized at the time of declaration. They cannot be reinitialized. Once you initialize it here, you cannot reinitialize once again saying min underscore is equal to 21. If you do like this, you'll immediately get a compilation error saying that final variables cannot be reinitialized. This is one way. The another way of declaring final variable is This option is also there. Actually, final variables should not be left without initialization. Remember that point. But this is acceptable. You can also declare final variables without initialization. You can also declare final variables without initialization. But rule is such variables must be immediately initialized in the constructor. And if you promise that if you initialize final variable in the constructor, then you can leave final variable with only declaration. You need not have to initialize it. If you promise to do this, you can declare and leave like this. Otherwise, at the time of declaration itself, you initialize it. Otherwise, you declare and initialize it in the constructor. Or do both again at class level itself. But initializing at the time of declaration and reinitializing in the constructor is not allowed. That is against to again final. The preferred way is initializing final variable at the time of declaration itself. This itself is correct. The next, when to declare final variable. There are so many examples on final variable. On final variable, we will discuss some more points. Here, in how many ways we can access a final variable. If variable is declared as final, every variable, irrespective of whether it is final or not, every variable in a class must be accessed using by creating object of the class. Without object reference, you can access a variable. For example, if you want to access this variable, finally, first of all, you must create object of the final variable class FVC is equal to new final variable class object dot min underscore age variable. And to access final variable also, we must first of all create object of the class. With the object dot, we must access the variable name. But in Java, if you find in many classes where we'll access final variables both using object dot variable name and as well as class name dot variable name also. For example, as I told you, min underscore priority, max underscore priority, and norm underscore priority, the three variables in thread class, they must be accessed using like this: thread dot max underscore priority. How come a final variable is accessed directly using class name dot variable name? In fact, the actual method of accessing a variable is by creating object of the class, and with object dot you must access the variable. How come the thread class max underscore priority variable is being accessed directly with the help of class name dot variable name? You will find in all the occasions swing constants dot north underscore direction. Similarly, math is a class, math dot pi. Most of the final variables we found accessed by using class name dot variable name, but not by creating object and object dot variable name. Not 99, almost in all the 100 occasions. Final variables are accessed directly using class name dot variable. But how is it possible? How a final variable can be accessed by using class name dot variable name instead of object dot variable name? Can you guess it? There is one access modifier. That always associate with final in Java is static. And every final declared variable is also prefixed with a static in Java, and also mostly with public also. Any variable of any data type declared in Java, any final variable declared in Java is mostly associated with the static and as well as public. And final and static combination are the most occurring combinations in Java. Why final variables are also declared as static. What is the benefit of declaring final variable as static? So, if I read across all these paragraphs, you can read all these paragraphs later on. I'll show you this with an example. Why a final variable must also be declared as static? On that, I'm giving an example. Here is one class given name called employee. So, how many variables exist in the employee class? The employee class is having employee name, salary, and designation. Employee ID, employee name, salary, and designation, these 4 variables are given in employee class. The intention of these four variables is as many objects of employee class are created. For example, in a school, the employee's strength maybe of couple of tens, like 10, 15, 20, 30. At max, in a school, the number of staff may be 50 to 100, not more than that. If you take any average of medium level school. Even if you go to college also, in the college also, the staff may be in couple of hundreds, 200, 300, 400, not more than that. Of course, in a companies, the number of employees may be thousands, and the government organizations like railway, they are having employees in lakhs. So school to college to some software development center or any manufacturing company to government organization, the employees will vary from a couple of tens to hundreds to thousands to lakhs. So we are writing this employee class to perform some operations on the employees, like calculating their salary or applying leave to them, or we want to show how many leaves are available to them, or we want to show their attendance, or we want to show their tax amount calculated. We want to show the deductions of the employee, or otherwise we want to show the student marks if it is student, their average, their total, and their grade, like that. As many employees as we are having in our organization, those many objects of employee class will create. And as many objects, suppose for example, if a school consists of 10 employees or a small organization consists of 10 employees, we'll create 10 employee objects. In all the 10 employee objects, the memory must be allocated to employee ID, employee name, salary, and designation. 4 variables. Employee ID, employee name, salary, and designation. Because in every object, we'll store one employee data. In this object, we'll store employee number 1 data, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the different employee objects consist of different values. Different values, nothing but different employees data. So, because these variables, memory must be allocated in every object of the employee class or instance of employee class. We can call them as objects or instance of employee class. Because to these variables, we want to create memory in every instance of the class. These variables are called as instance variables, IV. Instance variables means as many instances of the class are created, in those many instances, to these variables, memory will be allocated. So in one object, one employee data. Later on, we'll process something that is material here. Along with these 4 variables, I declared one more variable called a min underscore age is equal to 18. Min underscore age, and the minimum age to get the employment in company is the employee should be minimum 18. Then only we will take him into the employment. Otherwise, we don't take. So min underscore age is 18. Its data is int, because 18 is an int added and also declared as final. Because see, throughout the country, in India, the minimum age for getting employment is 18 years. That cannot be changed from our nation to our nation, or state to state, or district to district, or from our nation to our nation. In every organization, the minimum is to give the employment for an employee is 18 years. So is this value constant or not? Or this value will change from one organization to one organization? One organization will give at the age of 12, 16, 21, 25, like that? No. Right. Hence, we declared this variable as final. See, these variables are different. These variables are intended for storing different employees' data. But this variable value is constant for all the employees. 18 means 18 only. This cannot be changed from object to object. Here also it is 18, 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 18, 18, 18, 18, 18. Everywhere 18. It's a constant variable. The point is, look at this right side. We created two employee objects. In the first object, memory is allocated to employee ID, employee name, salary designation, and min underscore age variable. Because along with other variables, to this variable also, the memory is allocated. But in the employee 1 object, employee ID is 1, employee name is ABC, salary 50,000, and designation is developer, age is 18. This is employee 1 object. Employee 2 object. In employee 2 object, employee ID is 2, employee name is XYZ, salary is 1 lakh, and designation is architect, min underscore age is 18. And here in this employee object, the state is different from this employee object state. State is nothing but in that employee, to all the instance variables, whatever values assigned, that is called as state. Object means the variable values inside an object are called as object state. This is object state. But coming to this variable, up to now we created two objects. In both objects, to the min underscore age variable, the memory is allocated. The value is 18. Here memory is allocated for that variable. Here also for the min underscore age variable, memory is allocated. You create 100 or 1000 objects of employee, along with employee ID, employee name, salary, and designation. To this min underscore age variable also, the memory will be allocated separately in every object. Like that, if 1000 objects are created, 1000 into means 4 bytes. 4000 bytes into 4 KB. If you create 1000 employee objects, and in such a employee class, if you are having one final variable like with int type, 1000 into 4 bytes for each int variable, 4 bytes. 1000 into 4, 400 bytes, almost 4 KB of memory will be unnecessarily consumed. But out of that, the variable value of this min underscore age variable is constant across all the 1000 objects. When a variable value remains unchanged, why its memory being allocated in every object of the class? If variable is final, whose value is constant for any number of objects, why are you unnecessarily allocating memory in the instance memory of class? Or not wasting the memory? Okay? Declaring final variable as instance variable leads to unnecessary memory consumption, poor memory organization. That's the point. Final variables, their value is same across any number of objects of the class. Then why you are unnecessarily allocating memory in instance memory to final variable? So, declare such variables as static. Final static final int min underscore is equal to 18. Now you create 2 or even 1000 employee objects also. In all the 1000 employee objects, the memory will be allocated only to employee ID, employee name, salary, and designation. Only these 4 are instance variables. Only these 4 are instance variables. But not to this variable. Then what this variable is called as? This variable is not a instance variable. Instead, this variable must be called as class variable. All static variables are called as class variables. Static. The term, if you put static, it means that the variable is not a dynamic variable. Variables which are declared not as a dynamic variable, to them in instance memory, no memory will be allocated. This is not a static variable. It's not a dynamic variable, it's a static variable. If you declare any variable static, to that variable, the memory, instead of allocating in the instances of class, memory will be separately allocated in one more memory called class memory. So you tell me where static variable memory is allocated? In the class memory. To non-static variables, where memory is allocated in the instance memory. That's why non-static variables are called as instance variables and static variables are called as Class variables. Class variables. So you declare final variable as static. 1000 into previously 4 bytes memory unnecessarily allocated. Now only 4 bytes of memory will be allocated to min underscore base variable for as many number of employee objects as you create. And in these instances, only instance memory will be allocated to employee name, salary designation, but not to this final variable. Memory consumption reduced, optimized, better managed. Final variable if declared as static. If you don't declare a final variable as static, memory unnecessary consumption takes place. That is the point. So here, hope this is clear why final variable need to be declared as static is clear, I hope. Because of this reason, one more point is, because of this reason, the memory is allocating to static variable in the class memory. Such class variables can be directly accessed using class name dot variable name employee dot min underscore is. Static variables, because their memory is allocated in class memory, they can be called with the class name dot, because their memory is not in instances. If their memory is in instance memory, e1 dot min underscore is points to different location, e2 dot min underscore is points to different location. But the min underscore is variable, now memory location is in the class memory but not in the instance memory. So how can you call it as? You can directly call it with the class name dot variable name. You can also call with object dot variable name. Though you call with object dot variable name, static variable will be pointing to class memory. So a static variable can be called either with the class name dot variable name or instance dot variable name. Both are valid, both are allowed, both are valid. So now hope this point is clear. Hence, variables, final variables which are also declared as static can be called with the class name dot variable name, and final variables which are not declared as static, then they must be accessed using object dot variable. Hope this point is clear. So the most common combination of final variable is the final variable is also declared as constant variable. Hope static and transient, these two are clear, I hope. Now two more access modifiers left on the variables. They are transient and volatile. You can read this static later on. And it's just only a brief note about the two more modifiers we can apply on variables. One is transient and other one is volatile. Transient. The word transient represents opposite to persistent. Opposite to persistent. What is persistent? Not a transient. What is transient? Not a persistent. Persistent means anything which can be saved, can be not saved or stored. Anything that can be saved or stored is called as persistent. Persisting the records. Records are persistent into database. Documents are persistent into files. Files in the hard disk. Data is persistent in the files or database. Persistence means storing. In object-oriented programming, we use the term persistent for objects. As we discussed previously about employee object, in employee object we have employee ID, employee name, salary and designation. 4 variables. 4 employee objects we created. Like that, how many employee objects we have created? Suppose, for example, if you are running a small organization consisting of around 10 employees, let us say. Every month we want to calculate their salary. every month at 31st or 1st or 2nd, we want to calculate the salary. How are you going to calculate? So every end of the month, you go and fetch employee data from the database, the employee name, salary, designation, their master status, their present address, their permanent address, so their qualification 1, 2, 3, their email ID 1, 2, 3, their mobile number 1, 2, 3, the degree, PG, UG, PG, PhD, their first company, second company, third company. They're having lots of data. Currently, their position in this organization, to which department they belong to, which project are they doing, to which client are they doing. An employee class might consist of around some 50-60 variables, consists of this whole data. And plus number of days attended, how many leaves applied, how many are absent, all this data. So we generally store such an employee information into database in a form of tables and records. Tables. In the tables, we'll store it in a form of records. End of every month, we need to fetch all the employees' data based on the number of days attended, based on his base salary, per day salary calculation, number of working days into per day salary, the total salary you calculate. You exempt all the leaves and cut off all the leaves and absence, cut off from the salary, and give the remaining amount as salary to the employee. But for this, end of every month, our application should connect to database, fetch the employee data, process this, take some payslips printout, and just disconnect from the database. The copy of the employee data exists in the database. We fetch it into object. We'll do some calculations. We'll take printout of payslips and we'll just shut down all the objects. The permanent information of the employee information exists in the database table. That is permanent. But storing employee data in the database is also a space consuming, not memory. Memory means RAM. Space consuming means hard disk. Space consuming, and every time retrieving the same employee data from the database again and again is a time consuming, and network time consuming, application time consuming, database time consuming. There nothing good business stuff exists in the employee data. It's only just a static data, for which you need to fetch every employee data from the database and populate into employee object process. Then once employee object is created, again you create one more object and again get the employee data again. Repeat the same process. Will consume a lot of time. And for such a non-business data, instead of storing such information into data, I prefer product information. Most of the products information are static. Product ID, product name, price, or description. Once manufactured a product whose description may not be changed, price changes very less often. Their category remains same, their manufacturer remains same, their spec remains same. So why you store product information in the database? Why you store employee information in the database, the static data, the data which is not frequently modified? So, but how do you store such an employee data or product data instead of into a database, into a small file? For that, in Java, we use a concept called serialization. We'll write class implements from serializable, public class employee implements serializable. And the classes only which are derived from serializable interface and to which you create objects. These objects can be stored into files. There are objects that can be stored in files. Only classes which are implemented from serializable, only those class instance variables that exist in these objects are only stored in serializable files. And storing data in a serializable file could be a best alternative for storing the data in a database to reduce the cost effectiveness, to reduce the cost of utilizing the database. So, end of every month, you fetch employee data from the serializable file based on number of working days in basic pay, salary. You make some calculations, take printout of the payslip, and just quit. Remove all the objects, and data will permanently remain in the serializable file. For that, we'll do some object input same, object output same, named few classes we'll use in iOS streams to store the objects and to retrieve the objects. We'll do that stuff. In such an employee objects, if any variable or variables in such an employee object, if any variable or variables whose state do not want to be stored or persistent, whose variables do not want to be stored or persistent into file system are declared as transient. And in a class, if you declare any variable as transient, like here or here, if you declare any variable as transient, during object serialization, the entire object will serialize into serializable file except the transient variable. Transient means do not want to be persistent. That will be marked as transient. Transient, not persistent. That is about transient. We'll discuss more about transient in iOS streams topic. In iOS streams, we'll discuss that. And coming to the volatile also, regarding volatile also, I don't discuss about volatile much time here because volatile is used in threads, multi-threaded programming. Generally, in threads, we'll synchronize the objects so that the entire instance state in the object will also be get synchronized. But in thread synchronization, whichever variables do not want to be get affected with the synchronization, such variables are declared as volatile. And variables which do not want to participate in the object synchronization in multi-threading are declared as volatile. Volatile, prickle, unstable. Here not unstable. If in a class, if a variable is declared as volatile, and if that object is used in multiple threads, though one object locks the thread and other object is running on the object, that variable will not be get affected. The volatile variable will not be get affected. Anyway, we can see that it's a nice example in threads topic, the volatile variable. And transient variable I've already explained. Static along with final variable explanation is also completed. I hope we will end up the session with this topic here, and in the next session we'll continue variables and method, their declaration syntaxes and their consequences of applying access specifiers and modifiers, on methods and constructors. Constructors and methods are left. Classes or variables or constructor, the next followed by constructor and then method. With that, we will complete this programming structure topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.